Okay, if you are watching this video, then chances are very good that you have come across an acids and bases quiz, and it's asking you a little bit about the numbers on the pH scale. So this video is intended to address those questions that you're seeing. So I need to start with a drawing of a water molecule. It's got 2 hydrogen atoms and 1 oxygen atom. And imagine a whole glass full of these, a whole bunch of these water particles. What can happen sometimes is one of these hydrogen atoms can leave this water molecule, and so what you wind up with is this positive hydrogen ion. So it's this positive 1 charged hydrogen atom. It's beyond the scope of this video to talk about something called hydronium, so I'm just going to be looking at these 2 things. So I'm going to look at a water particle that has a hydrogen come off. And so when the water particle has the hydrogen come off, what's left? What's left is the oxygen atom and 1 more hydrogen atom. So this thing is called a hydroxide. And this thing, we're just going to call it a hydrogen ion. And so that's what this is all about. The pH scale is all about these things. And specifically, the pH scale talks about this one right here, the hydrogen ion. There's another scale that deals with the hydroxide ions, but I've never seen anybody use that. And that doesn't mean nobody does, but I've never seen it. So anyway, by this point you already know that if something has a pH of 7, we call it neutral. And now you should begin to see why. The reason why is because at a pH of 7, the number of these things equals the number of these things. So the OHs, the hydroxides, they tend to make a solution basic, and the concentration of these things, the more you have, that tends to make a solution more acidic. So without actually talking about real numbers, how many of these things are actually in water, we're just going to talk about sliding around on this scale. For example, going from a 7 to a 6. And let's do that first. So it might sound kind of counterintuitive, but if you go from a 7 to a 6, you're actually becoming more acidic. So as the numbers get smaller, you've got a stronger and stronger acid, and as the numbers get bigger, you've got a stronger and stronger base. But if you go from a 7 to a 6, what happens is the number of these things, the number of these hydrogen ions, goes up 10 times. So something with a pH of 6 has 10 times as many of these positive hydrogen ions as something with a pH of 7. Okay? And the same thing happens if you go one more step. If you go from a 6 to a 5, then you wind up being able to say that something with a pH of 5 has 10 times as many H plus ions as the pH of 6. So what does that mean? What if we compare 7 to 5? Well, if each one of these 2 steps was 10 times, then that means something with a pH of 7 has 100 times as many H plus ions as, oh poop, I said it wrong. I don't think I'm going to reshoot this. I'm just going to keep going. Something with a pH of 5, I'm sorry, has 100 times as many H plus ions as something with a pH of 7. So we could keep on going here. You know, if you had something with a pH of 4, then what would it compare to 5? Well, 4 has 10 times as many of these as a 5. 4 has 100 times as many of these as a 6. And 4 has 1,000 times as many of these hydrogen ions as a 7. So you get the idea that if you move around in this neighborhood, it's not that big of a deal. And if a biology teacher heard me say that, they'd probably be upset. But if you get down toward the low numbers, like down toward your pHs of 1, now you're talking some fairly dangerous substances. And likewise out this way as you get out towards 13 or 14. But anyway, I'm closing in on 5 minutes, and I just wanted to give you a quick introduction to how the numbers work as you slide along on the pH scale, and I think I'm done.